This video is about regular polygons. We're going to do some problems regarding them. And as always, I'll go over some important things that you might need to know before diving into these problems. So what is a regular polygon? A regular polygon has all sides congruent. Okay, so this is a specialized case of any polygon. Again, the key point for a regular polygon is all sides are congruent. And as well, because all sides are congruent, all angles are as well congruent. Okay? So the radius of a regular polygon is the distance from the center to a vertex of the polygon. So in this case, from Q to P, that is a radius from the center to a vertex. From the center to the center of one of the sides is called the apothem. Okay? And finally, the central angle is the angle formed by two radii. Okay, so this entire thing over here would be the central angle. It's just some vocabulary. Why are those important? Or what's important about those? Well, there's some theorems. So the sum of the measure of the interior angles of any n-sided polygon is n minus 2 times 180. So honestly, I just remember that formula by taking special cases. For a triangle, it's 180 degrees, so 3 minus 2, that's 1 times 180, 180, right? For a square, that is 360 degrees on the inside, there's 4 right angles, right? So n is 4, 4 minus 2 is 2, times 180, that's 360. So that's how if I forget the formula, I just remember those two special cases, and then I can remember the general formula. The measure of each interior angle of a regular n-sided polygon is n minus 2 times 180 divided by n. Okay? So you just basically sum up the total from the previous formula, n minus 2 times 180, divided by the number of angles. That's quite obvious. Okay, the sum of the measure of the exterior angles of any polygon is 360 degrees. That's key. So any polygon, doesn't matter how many sides there are. And the area of a regular polygon is half times the length of the apothem times the perimeter. Okay? That's the quickest way to find the area of a regular polygon usually. Okay? So with that said, let's do some problems now on this page. I apologize for this shadow over here. I'm trying this new setup. The figure above is an equilateral should be equilateral triangle inscribed in a circle with radius 10. Okay? By the way, inscribed means it's just inside the circle. Okay? What is the measure of angle AOC? What is that angle there? There's multiple ways, of course, you can do this. One way is to realize that it's an equilateral triangle. Okay? So that means it's a regular polygon. This triangle is a regular triangle. All sides are congruent. And what does that mean? That means this central angle plus this central angle plus this central angle should add up to 360. So 360, how many central angles are there? 3. That is 120. That's the answer. That's one way to do it. Another way to do it is when you learn about circles. Again, because it's an equilateral triangle, we know that this angle up here is 60 degrees, okay? This inscribed angle, if that term sounds familiar, is half of this central angle. So 60 times 2, 120, same thing. Okay, what's the length of OD? What is this length here? Isn't that the apothem? So how do we find that? Well, let's take this triangle out. Remember there's that theorem that says if you draw the vertical in an isosceles triangle, in this case it is an isosceles triangle because it's an equilateral triangle, so these two sides are congruent, right? These two edges. So then if you draw the vertical height, it would bisect AC, okay? So what's the length of AC? Do we know that? Let's see. Circle with radius 10. So this is the radius. Do we need to know that? That's fine. Okay, I don't think we need to know that because if this is 10, this is OC by the way, this is D over here, okay? This would bisect that 60-degree angle there, so it's a 30 degrees over here. So can we get OD? It is by special triangle, that is 5, is it not? Yep, that's the answer. 30, 60, 90 triangle, so this side, opposite to 30, is 10 divided by 2, which is 5. Okay, so again, the problems, a lot of the geometry problems require knowledge from other topics. So here, the topic was bisecting. It bisects the angle. Okay? What is the length of BD? BD is BO plus OD. What's BO? That's the radius of the circle, is it not? So 10 plus 5 that we just found, 15. What's the area of triangle ABC? So this triangle. What's the length of the base? Do we know that? We don't. Maybe we can use this. So if this is 5, this is 5 root 3. So DC is 5 root 3 plus another one. It's symmetric, right? Because again, this bisects AC. So if this is half is 5 root 3, this half as well is 5 root 3. So it's 10 root 3 total. So 10 root 3 times half. So technically I didn't need to do that, but anyway, half times the base, which is 10 root 3, times the height of the triangle, which we said was 15. So this is 5 root 3 times 15. What is 15 times 5? That should be 75, right? 75 root 3. Answer is D. Okay. Next, 5 to 7 refer to the sky. Regular pentagon whose radius is 6. What is the value of x? X is one of the interior angles. How do we find the sum of the interior angles? It's n, which is the number of sides, minus 2. So pentagon, there's 5 sides, so 5 minus 2 is 3 times 180. And how many angles are there? There's 5 angles as well in pentagon. Same number of angles, the same number of sides. So what is this? This is, if I try to do this in my head, that's 3 times, what is that? That is 3 times 36, right? I think. So 90 plus 18, that is 108. Is that correct? Did I do it in my head correctly? Let me check. Yes, good. Feeling a little rusty, but that's okay. What's the measure of RQS? Where's RQS? RQS. Okay. How can we get that angle right there? Well, what is the central angle? It's 360 divided by 5. There's 5 central angles, so 360 total divided by 5 times, and we want RQS. The central angle is the entire thing here, so we want half of it, because again, this would bisect that angle. So times a half. Okay, so this is 180, so 180 divided by 5, that is 36. Yep, that's right. Good. Okay, number 7. Which of the following can be used to find the value of A? Can I fit this all? Not quite. Actually, kind of. Okay. Sine of RQS sine would be SR over 6. So that's not right. No. Cross that out. Cosine of RQS would be A over 6. That seems right. Keep that. Sine of RQS we said was this length opposite over 6. So nope. And cosine of RQS we just said was adjacent over hypotenuse. So A over 6. So the answer is B. Okay, and that's it. Again, usually these problems aren't too bad, but it could get harder if you had to combine knowledge from different topics. So that's what throws most people off. But again, if you practice enough and really know these concepts well and don't forget them after the lesson, after each lesson, then you should be fine, okay? Hopefully this was helpful. Hopefully this was helpful to see in itself possible problems the exam could ask. So as always, please like and subscribe if you found this helpful in any way.